For my project for alternative energy, I created a hydroelectric plant. It's pretty basic. It doesn't put out a whole lot of power, but I did prove the concept. I'm going to demonstrate it in two ways. First will be via a waterfall, which you find, and if we had it on a stream. Originally, my water wheel was going to be put into a stream, but we didn't have enough rain for me to find a suitable place, so I changed it into more of a waterfall water wheel. This right here, we'll be using a hose that will have the water. This will be our water source. Our water will come down and will drop. It will go into the water wheel. The water wheel I created using a frame of PVC pipe and an old bicycle tire. For the paddles, I attached several cups on here to catch the water. So what will happen is the water will come down through the waterfall, will hit the cups, will cause the cups to turn. The bicycle wheel is attached to another bicycle gear up here, which is attached to the shaft, which goes into our generator. So as the bicycle wheel turns, it'll be turning the shaft. So, as I was saying, I have a bicycle chain connect to another bicycle sprocket up here. As the water wheel turns, the sprocket through linkage will go onto this shaft here. I have a couple of sealed bearings here that will keep the shaft straight. The shaft then is linked to our generator. I used a 12-volt fan motor for a car. I had a bigger motor, and I don't know if anybody ran into this. One thing you need to, when you're generating power from an electric motor, if you get a high-speed motor, in order to get any power out, you have to go pretty fast. So I stepped down to a smaller motor. This is allowing me to get almost 1 volt, maybe a little over, basically 100 millivolts out of it. So the shaft goes into our generator through a linkage that I concocted with the PVC pipe. I have to verify it, I have a multimeter set up. The multimeter, as the wheel is turning, the multimeter will register what the voltage output. I was talking about. If you can see right now, it's measuring 0.00 volts. I have it set for 2 volts now, but I'll be alternating between 2 volts and millivolts. Again, I can't produce a whole lot of power on this, but I do have proofs of concept. If you noticed, if you follow these up here, I just have the leads coming right off of my generator. I'm going to be using the waterfall first, which doesn't spin the wheel all that fast, and then I will just be taking the hose and putting it on the water wheel in order to get the wheel really spinning. So let's get into the demonstration. Before I actually put the water on it, I'll just give a brief demonstration on our water wheel. I'm going to give it a little spin. So if you look over at our meter right now, you see, if I give it a little spin, I'm just spinning the wheel a little bit, you'll notice it goes up, and I have that set for millivolts. So we're getting a little bit on there right now just from a little spin. So we're gonna monitor that when I turn the water on. Okay, we have our water wheel ready to go. We have an assistant getting ready to put some water down our waterfall. Our waterfall's coming. You get it directed at the cups, and it's turning my water wheel. Now, you can see the water wheel is connected to the gear. The gear is now turning the shaft. And now if we look at our multimeter, we have anywhere between 60 and 70 millivolts. If I change this over to 2 volts, we're talking 0.6 or 0.7 volts. And that's with using our waterfall. So it's not a lot of voltage, but it is proving the concept. One of the things here, we have to get it aimed right at it. So what I'm going to do is I'm going to stop and I'm going to put a nozzle on that hose, and I'm going to get the wheel spinning very quickly using the hose. Okay, we're going to give it another try, and this with a slight redesign. I took out every other cup on my water wheel. I want to see if this will have any effect on our voltage output. I believe the cups that I had on the amount were cutting down on the hydropower, mainly because we were getting splashes. So if you see, we have the same setup. Our meter's at 0 right now. We go over our linkage there, and there's our water wheel. So we're going to try the water wheel with again with the with the waterfall, and this is with half the amount of cups. Right away we can see that it goes up to 0.3 volts. 0.3, going up to going over to 0.35, and a lot depends on where the water is hitting that. You know, you wouldn't have to aim it so much if we were at a real waterfall, but we can see by cutting down the actual amount of paddles that were on there, we've doubled the amount of voltage output because it allows the wheel to spin faster. We were introducing a degree of friction when we had all those cups in there. So this proves that by cutting that down, we've doubled our voltage output. What I'm going to do now is I'm going to turn the water off, and I'm going to put a nozzle on a hose, and I'm going to spin the wheel as fast as I can to see what kind of voltage we can get that way. Okay, so now we have the exact same design as we had before, and what we're going to do is we're going to put a hose spraying right down onto that water wheel. We're going to see how fast we can get the water wheel spinning. You can tell right away it's going pretty fast, and now we're looking at almost a volt. If we can get that water adjusted just right, there we go. We're over 1 volt DC, 1.1 volts DC. So it shows we can get a pretty good output on this. And just as a side note, I did try this with all the cups, and I had to reshoot, and with all the cups on there doing the same thing, I couldn't get it up to this fast. So it tells the amount of cups and the amount of paddles that you have on your water wheel definitely affect how much output you're going to have.